I am Elham Fadaly. I'm a guest researcher at Eindhoven University of Technology in the Netherlands. I obtained my PhD degree in applied physics this year in April 2021. My research focused on the epitaxy of hexagonal silicon germanium alloys for the realization of efficient light emission for optoelectronics applications.
Hello, my name is Erik Bakkers. I'm working at the Eindhoven University of Technology in the Netherlands, and we have recently realized a new material which can efficiently emit light and can be integrated on semiconductor chips. So why would it be interesting to have a light-emitting material, you can ask yourself? And let me try to answer this question. So all computers are based on semiconductor chips, and on these chips, signals are sent around using electronic signals. And these electronic signals, they suffer from an electrical resistance. And due to this electrical resistance, energy is lost in the form of heat. And we all know that laptops, for instance, they can heat up significantly if we use them heavily. Another consequence of this resistance is that these chips cannot operate faster than they currently do. So why don't we use light instead of electricity to send around these signals on the chip? I mean, the whole internet is based on light, and it is well known that light does not suffer from this resistance. And if we would use optical signals instead of electronic signals on these chips, computers could use much less energy and also operate faster. Well, the main problem is that these computer chips are based on silicon. And silicon is truly a beautiful material, and it has been very successful, but the only downside is that it cannot absorb or emit light efficiently. So what have we done? So we have changed the crystal structure of this silicon, and it has been predicted about 50 years ago that if we would change this crystal structure, that silicon should be able to emit light. And normally the silicon, it crystallizes in the cubic crystal structure, and we have grown it in the hexagonal crystal structure. And this means that we have changed the way the atoms are stacked in this material. And recently we have demonstrated that this material indeed does emit light. And we believe that this is a very important breakthrough. So what are now the next steps? Our first goal now is to demonstrate that we can make a laser based on this new material system. And this is important in first instance because it proves that the optical properties of this material are really good. And secondly, for the final application, we want to use the special properties of laser light to distribute the information on the chip. Our second goal is to show that we can integrate this material in standard silicon processes, such that companies can also use it on their chips. I think this project is a very nice example of how fundamental science can be used to address big societal challenges, such as the energy problem.